Oh.
I see my face here.
Oui.
Yes, it's ready.
Voilà. Okay, so welcome everyone. We are normally live. So Paola, are you with us?
Yes, I'm here.
Hello. Hello. So we are going to begin this session. So session 3, we have 4 students who are going to pass. We have Camille, Ioannis. We will do a little break, and then we will have also Megan and Alexis. So as you remember, guys, you have 15 minutes to present, and then you have 15 minutes of question. We will open the floor to, of course, students if you have any questions, and to the jury. So I'm thanking, of course, Paola to be online, and we have also Eric and Hubert during the jury session. Okay? Camille, do you have your time with you somewhere?
No.
Or do you want one?
It's
No?
okay.
It's okay? Okay, so if everyone is ready, let's go. Paola, it's all good also for you? Okay.
It's good.
It's okay for me.
Okay, so let me just share it. Like this. Let's go.
Okay, hello everyone. Thank you for being there for the first presentation of this afternoon. So I'm going to present you the gathering of a 4-month internship with the company Fiber in close collaboration with the University of Quebec in Trois-Rivières. Within my presentation, I hope to show you the potential of algae to be included in an economic pattern in synergy with industries, municipalities, and local communities. So a little bit of context. Our study began in Quebec, Canada, and this industry, whose name is confidential, is emitting 2% of total Quebec greenhouse gases emission, although it is already trying to contribute to its reduction of its greenhouse gases emission. It still has a lot of process to get to this point. That is why one solution has been developed, which is the implementation of a CO2 biopark, including a lot of local stakeholders that are specialized toward conditioning, captation, transformation, CO2, but also the component of microalgae. So this is the component I'm going to work with. And so within this big project, the microalgae will be used to cap the CO2 as well as to convert the biomass, the protein from the biomass, into different sectors. And from this one, as you may know, microalgae are widely used for like a lot of things, such as food, feed, pharmaceutical, cosmetic, biofuel, bioremediation, for wastewater decontamination, but also for CO2 captation. Within the development of this big CO2 biopark, a big upstream research work was required. And so we tested many different microalgae strains, but within this presentation, I'm going to focus only in the Chlorella genus and especially the species Chlorella sorokiniana. So this species is widely used because it has been shown that it has a short generation rate as well as being fast growing, and it also showed that it might efficiently fix CO2 as well as having a good physiological response to high concentration of CO2 by producing a lot of metabolites. But when we cultivate algae, what is important is the mode of culture that we use, called the trophic mode. So you will have different trophic mode. I won't elaborate too much into this, but if you have further questions, we can discuss about it. And during this internship, I focus on the photoautotrophic mode because this is the mode of culture that is using CO2 as a source of carbon, which was really like useful and relevant for the application of the CO2 biopark that we want to make after. So, and with that, so the following question emanated: what would be the effect of gas exposure, specifically carbon dioxide, on Chlorella sorokiniana growth and its biomass composition? For that, we will have to fulfill many objectives, such as finding the best condition, having set and stable culture method and condition. We will also have to optimize the harvesting process and to target the specific components that occur in the biomass and compare them with the different conditions that we will test. And all of these to allow or not the scaling up of the project in a big industrial park. So what were the hypotheses that we state? We say that with increasing concentration of CO2, we will tend to have an increase in biomass content, in biomass productivities until, and this is important to note, until a certain CO2 concentration that might impact the algae. Then we will tend with, and this is usually the result of a autotrophic mode of culture with increasing biomass content. It might be at the expense of the lipid content, so we will tend to have lower lipid content, but with an increasing in fatty acid blend and the degree of unsaturation. With increasing concentration of CO2, we also expect to have more metabolite that will be synthesized. And in this other compound, it might include carbohydrate, vitamin, mineral, pigment, etc. And we were not expecting significant differences with the concentration of CO2 that we tested in terms of protein content. So we worked with two different volumes and with 3 different culture conditions. So it is important to keep in mind that we work with 2 different volumes, the following one of 300 liter and 2.5 liter, because although we will do a comparison of only the effect of CO2, this will have really to be extensively discussed because the comparison was complexified, because the 5% CO2 was cultivated in 300 liter, while the two other ones, the control that was not exposed to CO2 and the one that was exposed to 22%, were cultivated in 2.5 liter. I would have liked to perform everything in the same volume, but because of technical issues, and also because we wanted also to test if higher volume would have an effect. We tested in different volumes, but during this whole process of analysis, you will really need to keep in mind that disparities in the result might also be linked to the fact that we use different volume of culture. So quickly, the material and method for both conditions, we assessed the physico-chemical parameter, the daily concentration using 2 methods, optical density and cell counting. We also assessed the biomass productivities, and we did an extensive analysis of the biochemical content of our biomass in terms of lipid, protein, and what we called during this presentation the other compound that will include carbohydrate, vitamin, mineral, and pigment, because we did not have time to quantify all of them, so we will just do like the subtraction between lipid and protein, and this method will also be further discussed. We also tried to optimize our process of harvesting by working on flocculation tests, but this will not be developed, as well as the physico-chemical parameter and the concentration. So what we firstly saw is that in terms of biomass productivity, we tend to have pretty comparable biomass productivities between the control and the 22% CO2 condition, while it seems really lower in the 5% CO2, and this will be further discussed, but we were really thinking that it was because of the difference of volume. Then, in terms of biomass quality, so the composition, we looked at the biochemical content of the biomass in terms of lipid, proteins, other compounds, and in all of our conditions. So what we saw is that the highest lipid content was in the control. In terms of proteins, we did not observe any apparent significant differences in terms of protein content, but we use a NANOVA, and this will be further discussed because, as you can see here, it seems that in the second batch of 5% CO2 exposed culture, it seems lower, although the statistical test did not show any apparent significant differences. And in terms of other compounds, we can more see a pattern actually with increasing concentration of CO2. You will tend to have more synthesis of other compounds with an abnormality for, again, the second batch of 5% CO2 exposed culture. Then we look also at the lipid profile. So this is what we got. It's a lot of color, a lot of information, so I'm going to synthesize this for you. So this is what is appearing in color. This is all the fatty acids that were observed in all conditions. But what we can see is that the C17-1 was absent in the control, while we observed the longest fatty acid chain in the control, but not in the supplemented CO2 exposed culture. And what we also saw is that we had the C18 that was surprisingly only present in the 22% exposed CO2, while in the lower concentration of CO2 or in the control, we observed the C18, 2, and 16. We also wanted to look at the degree of unsaturation because like when you do a lipid profile, you can obtain for small environmental differences, you can obtain really different profile. But what is really interesting is actually to look at the different type of your fatty acid, but in terms of saturation. And what we saw is that actually it seems that the more you increase the concentration of CO2, the less you will have a lipid with high saturation, although the opposite trend was expected. So quickly coming back to our hypothesis, we saw an increase in, we were expecting an increase in biomass with increasing concentration of CO2, but what we interestingly saw is that the biomass with 20% CO2 and control were comparable. We fit with the hypothesis in terms of lipid content and other compound, although it was observed higher in the second batch of the 5% exposed CO2, but the opposite trend was observed in terms of fatty acid length and unsaturation. This can be discussed because of many reasons that we face. So first, what I mentioned, and that is a key point of this presentation, is the difference in volume that we still wanted to make a comparison, but that complexified the comparison of the results. And also we had in the highest volume, we had a contamination by another algae that was in competition with our culture, and this greatly impacts the whole biomass quantity at the end also, because it has been shown that Cynidismus could actually feed on this algae, and because of that, the biomass quality was really degraded, and it made the harvest process difficult. And also, we had a bias in calculation of biomass productivities and in whole content, because we didn't know for this condition whether it was actually Chlorella or it was Cynidismus content in terms of lipid proteins. We also had a lot of other problems, such as the fact that, for example, for the lipid profile, when we did the lipid profile, we keep the sample that were exposed to higher concentration of CO2 longer in the fridge, and we were doing successive thawing and freezing process, and this greatly impact our sample, which might result in lipid peroxidation, and this is targeting the polyunsaturated acid. That is why we think that we observe this opposite trend, that like with higher concentration of CO2, we had a lower degree of unsaturation. It was because actually these polyunsaturated acids were there, but they might have been oxidated. And so to conclude, despite of many challenges, this study still allowed us to gather supplemented data that help to open toward new studies into the CO2 fixation abilities, as well as using the biomass for further valorization. But yet we need to first increase our repeatability, because all the batches as well as the biochemical analysis were performed in duplicate, which did not allow to do too many statistics. Again, the volume of cultures, the methodology of other compounds need to be improved, because we only did the subtraction, as well as we did not fully consider the moisture content of our sample, so this might greatly have influenced everything. And Kumar and Al actually showed that the carbohydrates, or what we consider in other compound methodology, could represent almost 25% of the whole algae, so this might also be interesting to consider them with a more accurate method. So I wanted to thank all my team, and also all the board that welcomed me, for their availability and adaptability before, during, and after my project. And I also wanted to thank the MARRES board also for their availability even out of the scholar moment. And yeah, here is my email if you want to contact me. Thank you.
answer some questions. Do you have any question, guys, first?
Yes, we have a question. You mentioned during your material and method the flocculation test. What is the principle of this test and how did you do this test?
Okay, so yeah, I did not present it, but basically, when you are harvesting algae, you will always have to test without like doing your flow. Usually, you always like it was stated that they use the same flocculant every time, but since we had a lot of problem in harvesting, we wanted to investigate what flocculant will be the best, and I wanted like to maybe I think I have an appendix on this. It's here. Yeah, so basically we use spectrophotometry method and we measure, we took an algae sample in like, I will quickly answer to all our other question, but like we took an algae sample in 100 milliliter and so we measured the absorbance before and then we put the flocculant. We tried to only have a concentration of 1% of the biomass dry weight. And so then like we did the flocculation, we allow all the aggregate of algae to sink, and then we measure the absorbance after, and we made the difference to test on the efficiency. And then on the most efficient one, we tried what we called a sinking test. That was to look at like how long this aggregate took to go on the bottom. That revealed also that also helped to know like which one is the best because if they sink faster, it's better for us to harvest.
Thank you.
Do you have other questions? No? Okay, so Paula, do you want to go?
Yeah, I have several questions. First of all, many thanks, Camille. It was very clear, very pedagogic. I congratulate you for your presentation. I have two main questions. The first one, it's more on your replicates, on your statistics, and on your conclusions. It's not extremely clear for me when you do the statistic what you are testing exactly, and how I understand that the biological replicates are 2 for each conditions. And so what are the variability and the variation that we can show on your graph, where they come from, and how you can then state it the statistic on the top of that?
So first, thank you for your question. First, it was really difficult to do statistics because, as I mentioned, we only did our culture in duplicate, and when because of the facilities, maybe you know the GCMS apparatus. When we did our lipid, we also did it only in duplicate. So I couldn't do statistics because of that. But why do I? This is maybe what you wonder. Why do I have statistics for the proteins? Actually, we do have statistics for the proteins because I merge like the batches together. But like I merged batches of, for example, 5% exposed CO2A and 5% exposed CO2B together, and I did a statistical test. But I did not do it for the other because proteins, when I firstly looked separately at how my proteins look like in different batches, and I saw like visually that they might not be significant. So I wanted like to test it statistically these because I had time. But for the other, the lipids or the other compound, visually the difference were that strong that I didn't want it to do a statistical test and to merge the condition because I really wanted to highlight this. And when doing an ANOVA, like this test, maybe it's also that my knowledge was limited in which test I could use statistically, and my supervisor couldn't really help me in this because she had more an industrial point of view, so it was tricky. But when you are doing an ANOVA, it consider like all your data as a group, so it consider like it say that there is not significant differences in all your group, but it's not considering like between the batches. So that is why we did not see significant differences for the proteins. I don't know if it's
Yeah, it's not totally correct. If you have difference between two batches, the ANOVA will tell you that there will be some differences, and then you have to do a postdoc to see in which differences between each other you will have. So if you will have differences, the ANOVA will tell you.
Okay.
But you will not know where the difference
Well,
is.
these differences are.
Exactly. My second question, it was more on the concept of an increase on CO2 will decrease the lipids. And could you explain me the link between an increase of CO2 inside the cells, around the cells, and this decrease of lipids?
Okay. So there is a bit actually in the literature. There is a bit of conflict of interest between whether these lipids should decrease or increase, because lipids generally increase when the algae are stressed. So you will tend to have, and if you put them more CO2 than they want, they might be stressed, so it might increase. But why we were making this assumption is because actually um, we based, it might be not the most scientifically way of thinking, but we based our results from what a previous study did, and they saw this pattern. They saw that when, well, as I mentioned, to a certain detrimental concentration of CO2, but from a range of 0% of CO2 to I think they tested up to 50% of CO2. They saw that actually it was decreasing the lipid content. But also, I think it's also related to the mode of culture that we use, because we use trophic mode of photoautotrophic, and with photoautotrophy, compared to the other mode, we will tend to have lower lipid content in general. While, for example, if you use mixotrophic that also use an inorganic but also organic source of carbon, this decrease in lipid content will not be that high, that significant.
Okay, but you don't know exactly the link between the increase of the CO2 inside the cells and this decrease of lipids.
No,
What
because
kind of biochemicals pathways are activated to decrease this lipids content?
I don't really know, because as far as I remember, I know that they we did not really investigate it, and that will be in our perspective. It's like the CO2 fixation ability. I know that they have, depending on the species, they have what they call CCM, CO2 concentration mechanism, and I know that is happening in the cytoplasm, but I don't know how it might be related to the lipid itself. And also, like, I know that there is studies for Chlorella genus in general, but for this species in like the CO2 concentrating mechanism is poorly understood yet. And there is like, we don't know exactly if they fix, if they uptake. There is like really, so I don't know how, I
Yeah.
know that there is mechanism, but I don't exactly know how it might be related to the lipid.
I'm not expert in green algae, but very often in the algae, an accumulation of lipids, it's more like a sign of reserve. So if you decrease the lipids, that means that you use this reserve, perhaps because you need you have a need of trophic needs, and so you consume these lipids for the metabolisms. But I'm not sure if it's the case on in Chlorella.
It makes sense. It might be related, because I know that for the proteins, when we calculated the proteins, we looked also at the ratio in carbon, nitrogen, phosphor in the cell.
Phosphorus.
For the control, where we observed more lipid, we had a higher content in carbon. So that might also like fit with the lipid, this higher content of carbon.
Mm-hmm. Thank you. Thank you very much, Camille.
Thank you, Camille. Nice presentation. In your first slide, you showed the context that you want to use your microalgae production for food, food and feed. I assume that the smoke you use to feed your microalgae are not very nice for health. What do you think about your about the valorization of that you present on your slide?
Okay, yeah. I think it was not clear enough what I wanted to highlight in this context slide. It was to show like the general use of the algae, like that they can be used for food feed. But I'm not sure that within this process of a CO2 biopark they will use. They were talking about valorization. Well, they were talking about valorization of the protein of this biomass for fisheries and aquaculture, but I'm not sure they will use it for human consumption, like this valorization.
But even for fish, do you think it's relevant?
I think like to use this protein might pose social and health issues, but I was not that implied in the big project to know whether they will actually do that. I know that the main use of the algae that they want to do is to fix the carbon, and they want to valorize the biomass, but that's true that it might be a problem when it comes to consumption. Also because like these, like we talk mainly about CO2, but actually these are not the only effluent that there is in the salmon plant. You have NOx, you have SO2, you have a lot of gas that might be. So yeah, that might be an interesting question to ask if they really want to apply this to food.
In your experiment, did you use real smoke or just pure CO2?
The way we did it, we used like a bottle of CO2,
Okay, it's not the
and so we diluted with we split the flow meter and we dilute this CO2 in air. But yeah, also I only tested. They wanted me to test the other gas, but we did not have time because each culture were kept for 30 days, like the big cultures, and in a 4 month internship it was tricky. But we wanted also to test the other gas, and this I think they don't do it with the smoke. They do it also with bottle of gas that they dilute in different flow meters. They have flow meters in three that split, and they.
But the idea is to use directly the smoke of the
Yes.
industry. So what is your point of view? Because so you show us results that will probably not be the reality. So what is your point of view if we use the real smoke on the macroalgae productions?
I think like in terms
of productivity, for instance.
I think also like the smoke, as I see it, will be more in a dispersed state. It will not go directly on the algae, while during our experiment it was going directly. So I think it will be a big limitation, and to be honest, like it's been I think 5 years that they are trying to develop, and I think that in terms of feasibility, if they want to apply it, they cannot like direct the effluent gas directly on the algae basin. So I'm not sure it will be really feasible.
Why?
Because like the algae might not be able to fix directly. Well, I don't have the plan of the industry in mind, but like where they want to put the algae basin is pretty far. So I'm not really. It's pretty far from the actual industry.
You
So-
can take a tube, put the
You
gas
can okay.
on
This
the
I didn't
basin,
know
and
about it.
if you bubble this gas in the culture of macroalgae, what is because there is okay, we assume we don't know the industry you are speaking,
Okay.
but you know it, you know more or less the composition of the gases, so you just look at the CO2. So I want to have your point of view to try to be critics of how far are you from the reality. If you do what you want to do, it's mean to bioremediate the gas from the smokes. So what can be arrived if we use this smoke directly on the photobioreactor where there is macroalgae? What it will happen in the productivity?
I think the productivity is really likely to decrease, and I think that because they have two aims, fix the CO2 and valorize the biomass, and I think that the second aim of valorizing the biomass might not be fulfilled. You might have the fixation as they expect, but I'm not sure like it will be for sure detrimental to the growth. And I think we are likely to expect a decrease in, and even like if they fix the CO2, it doesn't mean that then like they will be able to aggregate enough to have biomass harvest.
I have a follow-up question on this slide. Do you know the concentration of CO2 in the smoke that is released by the?
I think it was 17 between from 17 to 25, if I remember well.
Okay, the question behind that is that I think when you order your bottle of CO2 and air liquid, I think it's recycled CO2. And I don't know if you can, perhaps you know better, but if that is sort of extracted from smoke from the industry, that is then. So my question here is, do you think that you can, rather than putting the whole smoke on your agriculture, is having a step in between that sort of filters out only the CO2 so that you have pure CO2 that is public and not the toxic stuff?
I would say that if we test for these small volume of culture, because it was really homemade PBR, so it was easy to move it and to put if we want to put a tube. But with the big photobioreactor that we have here, I'm not sure that with the features that we have with the tube or ability to, like for example, plug a tube as like sending this gas, I'm not sure it will be really it could really be implemented. I'm not sure we can do that.
Two small other question and to be over.
We have to move on.
There is did you measure pH? Because there is a very strong link between CO2 and pH.
Yes.
So what is your point of view on this aspect? Because you don't speak about pH.
Okay, can we come back? Where was it? Yeah, well, for sure, like we injected CO2 not constantly. We injected CO2 only when pH I think was exceeded 6.7.
Okay.
And so while for the control we did not inject, so the pH was around 8 for the control, while it was around 6.6 for the other. So for sure, I think that is why also the control showed differences, is that the pH was.
So the CO2 was provided on demand. It was linked
Yes.
to the pH.
Yes. Well, it was tested. The big project is to implement the CO2 biopark, and so they did like a lot of complement tests within my involvement. I did this, but I agree with the fact that comparing to the big project, it's not really close to the reality. But I know that they are also trying to to cultivate already in 10,000 liter, I think. But it's like a long research process, and
If you, I will try to be short, but if you add CO2 on demand, do you understand why there is no difference between the control and the 22% CO2?
maybe because it's just to regulate the pH, so that is why there is no differences. That's a good point.
Just a last question. Have you checked, you measure fatty free acid with 17 and 21 carbon.
Yes.
Did you check that in the literature, because you maybe have a Nobel Prize?
Yeah, I mean, can you repeat?
Did you check it's possible
To
to
have
have
such.
this kind of fatty free acid? Yes.
Yeah, because like interestingly, it was it was all these graphics showing fatty acid that were present in relative abundance superior to 1%, and this one was actually occurrent, and in the previous study that was published by my supervisor, she found similar results.
Okay, but normally it's not possible
To have such.
to have impair because the way to produce fatty free acid is to add 2 carbon each time. So you have necessarily 17, 18, 20, 22, 24. So maybe there is something else that is disturbing the measurement, or
maybe
you have to check in the literature that in this Chlorella, etc., there is other guys finding these things, but
I think.
first time I see that on my life.
I think that for this fatty acid, it's true when I compare although like it's tricky if you don't have the same condition to compare with literatures, but that's true that for the C71 and it was the C18 3 and 3, these one were not observed in other literature rather than the one of my supervisor. So I would also assume that they had a lot of issues with the apparatus, with the GCMS. So it might also detect acid that might not be there. But that's true that when I confront with the literature of my supervisor, well, we were matching. But when I confront it with other literature, they will tend to have in really higher abundance the stearic acid, the C18, but not, and for us, we did not have it that much.
Just normally in the metabolic approach is not possible. So
Okay.
I have to check.
Okay, thank you.
I had a quick last
Okay,
question.
last
So
question.
I didn't understand your argumentation why in the 5% you see a drop in biomass production.
Oh, because we oh, you want to.
No, okay.
Because we had, well, there is 2 points. First, it's difficult to control big volumes, and with big volumes comes what we call the photoadaptation period. So during this period, you will have the algae that will be really vulnerable, and they will tend to bleach. And at this time, we observe that they might be vulnerable, for example, to other contaminants. And what happened in both batch, but especially in the second batch of 5%, is that we had a high contamination by another algae and also by grazers. And our other algae that was like here, we did not perform an identification, but because of the morphology, we assumed that it was Synedismus. And Synedismus has a strong plasticity to grazers. So when we had grazers in parallel, it was not impacted, it was continuing, but the chlorella were really impacted, so it decreased in the biomass. And also like with presence of another algae, the biomass, let's say when you harvest the biomass, it must be compact. And like because of these two algae, the aggregation, depending on the species, you don't use the same pH, you don't use the same sproculant, and so the aggregation was not optimal. So the biomass was just like going through the filter, and that is why also when you calculate the biomass productivities, I don't know if they have optimization of this method, but it's pretty a gravimetric method. You do day one minus, the final day minus day one, and so this is how you obtain it per the total day of cultures. But it's like really a gravimetric method. It's just weighting a dry sample and a wet sample before. So that might be also a bias because the productivity might be the best, but since we did not harvest it like optimally, that might be one.
Good, thanks.
Oh, good. Okay, thank you,
Thank you.
You went so fast, I didn't have time to show you like all the good, nice comments you got from Mariana and Camille. Okay, so we are going to move with Ioannis now.
Yes. Thank you. So, Crystal, I assume you put the nice file, the correct file.
Of course.
Thank you. It's down.
Ooh la la. Okay. It's period, yeah?
Yes.
Yeah.
Perfect.
So if you want just to check if it's moving, so if
How do I change this?
just from below.
Spoilers. Okay.
All good? So if we are ready, so it's your turn. You have your timer with
Yes,
you.
yes.
Okay, let's begin.
Perfect. So let's start. So hello everyone. Thank you for being here for my presentation. I'm very excited to present to you today my Immersion project with the title Sedimentation Rates in Posidonia oceanica meadows at natural carbon dioxide vents. Without further ado, let's get into it. So we know that the atmospheric concentration of carbon dioxide keeps rising because of anthropogenic pressures. Specifically, it marked its highest concentration of the last 800,000 years very recently. Part of this carbon is actually absorbed by the ocean and stored there. And specifically, the carbon that is absorbed and sequestered in the sediments by vegetative coastal ecosystems is called blue carbon. And why vegetative coastal ecosystems? Because they're very efficient in actually fixing the atmospheric carbon, storing it in their living and non-living biomass, and also depositing it in the sediments below. These ecosystems include mangroves, salt marshes, and seagrass beds, or meadows. And speaking of seagrass, Posidonia oceanica is an endemic Mediterranean species that it's actually considered to be the most effective seagrass species in terms of carbon storage. Why does it happen? Because it has this structure below the ground, which is called the long rhizomes, which favor carbon storage. And it puts it into the sediment by depositing part of this material. Unfortunately, I mean, we don't know much of the ability of Posidonia oceanica of sequestering carbon in terms of global change and global change trends like ocean acidification. What we know is that Posidonia oceanica has greater below-ground biomass in naturally acidified conditions and high productivity. So how can we check that? How can we check carbon sequestration? What we can use is natural acidified conditions. For example, in Ischia, we have volcanic vents that naturally acidify the water locally by pumping carbon dioxide within the water. So maybe you can use, for example, these natural labs to test carbon sequestration. So how do we test carbon sequestration? First, we look at mass accumulation rates, or else sedimentation rates. On this picture here, you can see a sample core, sampled vertically from the soil. So this represents a part of the soil. Mass accumulation or sedimentation is how fast the particles come and deposit themselves here on the sediment core. And then what we do is that we measure the carbon content of these particles deposited on the sediment, and thus having our carbon sequestration rates. But regarding the first aspect, which is very crucial to calculate carbon sequestration, the sedimentation rates, how do we do that? We use radioisotopes, or else atoms that use nuclear material at a fixed rate. These atoms are unstable, and thus they go through radioactive decay. If you have more questions about that, feel free to ask me afterwards. If we know the concentration of them in the sediments, and we know at which rate they actually go through radioactive decay, we can have a dating tool. And specifically, speaking of radionuclides, what we use for sedimentation rate is lead-210. Lead-210 is divided into supported lead-210 and unsupported lead-210. And now you might wonder what is unsupported and supported lead-210. So let's go over this graph. We have uranium-238, which naturally occurs in the soils. This further decays to 226 radium. 226 radium decays to 222 radon. Part of it diffuses in the atmosphere, further decays to the unsupported lead-210. And this unsupported lead-210 goes and deposits itself on top of the sediments. While other part of this 222 radon, goes and diffuses in the seawater with more unsupported lead-210 depositing itself on top of the sediment. While another part actually remains within the sediment, further decaying into the supported lead-210. Supported lead-210 has constant activity and concentration through the whole sediment. So what do I see if I sample a sediment core? We go here. We see the supported and the unsupported lead-210. The supported has constant activity and concentration through the whole depth. You can see here the depth. Well, here you can see the specific activity which is proxy for the concentration. Supported has constant activity, while unsupported, since it's deposited, it has higher activity and concentration on the higher parts of the sediment. But as time passes and it further decays with radioactive decay, it goes lower and lower and lower in concentration. So, moving on, one major remark that I will highlight here is that different sediment types have different affinity for lead-210 in general. More coarse sediments like gravel have less affinity, while more fine sediments and clay in general have more affinity for lead-210. Additionally, coarse sediments are more prone to mixing within the soil, which means they do not actually remain stratified in the way they were deposited, but they mix, while fine sediments usually remain stratified within the soil. So, taking into consideration everything that was said, we hypothesized that sedimentation rates under the influence of carbon dioxide vents are higher than those in ambient pH conditions in Posidonia oceanica meadows, obviously. And how did we test this hypothesis? We went to the team went to the island of Ischia in Italy, where natural carbon dioxide vents occurred. And there were 3 sample sites: Vulatura, Castello Sud, and Chiandello. Out of these sites, 14 cores were analyzed in total, and these cores were sampled in 3 different pH conditions: ambient pH, low, and extreme low pH. You can see an average of this pH under each dot. Just a quick overview of the sample sites, starting with Castello Sud. In here, the first number you can see is how many cores were analyzed, and here is how many cores were actually sampled. If you have questions about it, again, ask me afterwards. And you can see regarding cores sampling ambient pH conditions, controls we have here, low pH, extreme low pH. Moving on, Vulatura, again, you can see analyzed versus sample cores, control, extreme, and low pH. And then moving on to Chiandello, you can see analyzed cores versus sample for control conditions and just low pH conditions. You can ask about it afterwards. So what we did in the laboratories actually, we took the sediment cores, we opened them, and first we did a visual description of what sediment type these cores have and other materials we might find inside, like the roots of Posidonia, for example. Then we sliced the cores in aliquots in terms of depth. For example, this is the upper part of the core, and we started slicing like this. These aliquots then went through acid digestion in order to isolate the radionuclides that were of interest, and then in alpha spectrometry, these isolated radionuclides in order to quantify their activity. Moving on to our results. So, instead of me presenting you every single profile that I obtained, I chose out of all the core samples from different pH conditions and sample sites, I chose to show you specifically 3 main sedimentation profiles, let's say, which will be used afterwards. The first one we can see is in Ischia 6. In here you have accumulated mass, which is a proxy of depth. Higher is closer to the surface, lower is closer to the deeper part of the sediment core. While in here you have the total activity, the activity of the total led to 10, both supported and unsupported. What we see here, for example, with the red, is the total led to 10. With the blues, we see the supported led to 10 activity. Actually, it was measured through radium 226 because they are in equilibrium, but it's the supported led to 10 activity. And green, which is in our interest, is the unsupported led to 10 activity. And as we see here, as the sediment was deposited, we have more activity in the higher layers of the core, while as we go deeper and deeper, less and less activity because it decays through time. Then we go to Ischia 3. This is what we say a mixed core, because as you can see, the activity of the unsupported led to 10 does not follow the sedimentation profile, like the profile through which it was actually deposited there. So what we see is like we have different activity here, while here in greater depths, it actually has even more activity, which shows that the sediment inside the soil actually was mixed. And then we have Ischia 12, where we have an intermediate actually profile, where we do see some parts where maybe the unsupported led to 10 follow specific reducing trends, depletion trends, but then here, for example, we see higher activity. So there might be some mixing, but still for some of them we're able to calculate the sedimentation rates. So in here, what I did, going on to the results of the slow transition to the discussion, is to make a great synthetic table with the majority of my data in order to highlight trends. What you can see here in the first row is that the different pH conditions at which the cores were sampled. First, we start with control, then low pH, and then extreme low pH. While in here, you can see the sites at which the cores were sampled: Castello, Vulatura, and Chiandello. Moving on, I just add the number of the core that was sampled in each condition. For example, core number 4 was sampled in control conditions in Castello Sud site. What we see here is that we have different number of cores analyzed for each condition. For example, Castello Sud, we have just 1 core analyzed in low pH, while, for example, for Vulatura, we have 4 cores analyzed for low pH. And then I started adding the sedimentation profiles. 3 arrows indicate higher sedimentation rates relatively, and 2 arrows a bit lower sedimentation rates, and 1 arrow even lower. For the course, we were able to analyze the sedimentation rates. These arrows here indicate mixing in the core. Sometimes this prohibited the total calculation of the sedimentation rates, and sometimes we could still calculate the sedimentation rate even though the core had some mixing. And this line shows that we didn't have enough material, enough lead to 10 actually some activity in our core, so we could not calculate at all sedimentation rates. So what I do here, I just add this profile on my table. So we can start now discussing a bit about the table as well. For example, in the extreme low condition, extreme low pH condition, we see actually only 2 analyzed cores have comparable sedimentation rates. When we go to the low pH condition, we do see, for example, this core was actually calculated for sedimentation rates, even though it did show mixing. While this core, we had clearer sedimentation rates with not much mixing inside. While for Chiandelum, we had mixed core, partially mixed cores, and so on. So this variability of the sedimentation profiles might not allow us actually to see specific, let's say, trends regarding of the pH for its profile. But this is again qualitative approach, and these are indicative first data. And also there are limitations here. For example, we can see here we just have one some core, here even more, and so on. What a positive trend that we can see here is that the sedimentation profiles might be actually site-specific. For example, in Vulatura, we can see a lot of clear sedimentation profiles. For Chiandelum, we see mixed profiles, and for Castello, we see a mixed profile here, and so on. But again, given the different amount of cores analyzed for each condition, we have to interpret this data very, very carefully. Speaking of sediment types that I talked about in my introduction, what we did is to add also the sediment types for each core analyzed, from more coarse sediment to more fine sediment. One major point that I want to highlight here is that we can see that in the extreme low pH conditions that we have these nice sedimentation profiles, in both cases we do have fine sediment, and we know fine sediment usually is kept stratified. So there is a question here that is the activity of the vents actually forcing these sedimentation profiles, or is the sediment itself? So we have to be very critical about it. Then what I want to highlight as well, for example, in Vulatura, we have in general very fine sediment, while in Chiandelum, that we saw a lot of mixing, we have coarse sediment. And a last point I want to add here is that some of the cores do have more than one type of sediments, and sometimes even very, very different. For example, core number 10 does have gravel, which is very coarse, but also have fine sediment. And we just in here want to remind that different sediment types have different affinity for lead to 10. Some general remarks. We do know that there are a lot of processes in general, especially in vegetative coastal ecosystems, that force the sedimentation profiles. For example, we know that in Vulatura, where we had our nice sedimentation profiles, we do have anchoring. And in Castello, where we had a bit more of mixed profiles as well, we do also have anchoring. But what we see is one side has nice sedimentation profiles, and the other side does not have as nice, even though the sampling effort was much less. So in here, we want to see that, yes, indeed, there are other processes of forcing these profiles. I want to highlight how important it is to have an accurate knowledge of if you have sedimentation profiles or if you have a mixed profile. Because, for example, if you start thinking that a mixed profile might be sedimentation profile, then the carbon sequestration data that you will get afterwards will have a much different story of what is actually happening. And also these samples, as we talk, are going to be analyzed for carbon content, and so on. And this also can highlight specific sedimentation process. For example, if we use carbon isotopes, we can have an idea of if the carbon that is sequestered here is allochthonous or autochthonous at first, showing some sedimentation deposition in our site. And as a conclusion, going back to our initial hypothesis, since, for example, in our controls, we didn't have much calculated sedimentation rates, and we saw in general a lot of mixing in our course, we're not able to compare sedimentation rates in terms of proximity or to the vents. If we were to talk about a potential trend, that would be that the sedimentation profiles are site-specific, but still we should be very careful in the implementation of this. And I want to highlight, obviously, how significant this project is and how it's going to contribute to have an idea of how Posidonia oceanica's ability to sequester carbon might change with in the terms of ocean acidification or naturally acidified ecosystems. So that's all from me. Thank you very much for your attention, and a great thank you to my supervisor, Nuria Teixido, Steve Comon, and Pera Massi. And
Thank you, Ioannis.
you're welcome.
So I'm just turning first to you.
It's an intense topic, I know, guys.
So do you have any questions?
Feel free to ask me.
Oh yes, we have time for them. No? Okay, so perhaps we will start then with the jury. Will you want to start?
I can start.
Okay.
Thanks first for the very interesting presentation. So I was wondering, so you don't see it. It's preliminary, so you may need additional samples to get a better picture of it. But what are other environmental factors that could affect the sedimentation? You talked about anchoring, but I also saw currents, turbidity.
Okay, so we have like some major forces, and is also what we were also describing while describing the course themselves is the presence of roots. Because Posidonia, as it moves its roots itself as a species, it carries attached sediment to it, so it can provide more mixing. Then we have neofauna that lives inside the sediment, which, as you know, also does some work in the sediment, so it also affects mixing itself. Then we have anchoring. We have also erosion, which in this case, we don't have erosion here, but in this case, it would remove the activity of the surface layers of the lead 10. And then there are more and more.
So when you sampled, I guess you had sort of a visual cue that the sampling sites are similar, so that you have a constant coverage without any patchy sands or something, which indicates anchoring. So
yeah. I don't understand the question.
No, it's you said that this can change or this can affect, but the question is, are you sort of sure that the conditions are equal in those different sites? Is there a myofauna analysis done in parallel? Because anything that you said, so what can influence?
No, we're absolutely
multifactorial aspect, but
we're actually not sure of that. I hear a noise here. We're absolutely not sure of that, and this is one of the reasons, for example, because in the last site, Jan de Loom, we don't have an extremely low sampling. We do know that these sites vary between themselves, and also in terms of the activity of the vents and the intensity of the activity of the vents. So it's the approach to this project was to see what is a general idea of the sedimentation profiles in these three sites that show the volcanic vents, and then to see if we can calculate carbon sequestration rates. But we do know from the beginning that these sites vary. For example, Jan de Loom, which is the deepest site, doesn't have the vessel activity that Castello and Volatura has, for example. So yeah, it's the vary sites themselves.
Then just a curiosity question. On some of those pictures, there was your name, but the year, is it the publication or is it the copyright of the picture?
It's the copyright of the picture. It's about to come. It's about to come.
It looks like it's already published.
Oh, sure.
That was fast.
Okay.
Okay, thanks.
Yeah.
You want to go?
I don't know if I hear some noise from the video.
I think it's just.
Okay. You organize Crystal Bird. I don't know.
Okay.
Paula.
Go. Paula, you will be last. Just we have to
The sedimentation, to be sure to understand,
Of course.
the sedimentation rate is finally function of the growth rate of the Posidonia. This is below hypothesis.
Exactly. Because the main function through which Posidonia can affect the sedimentation rates is by depositing non-living organic material in the sediments. There's also another one, but it's much minor, but we can discuss about it.
So it's already a question of pH, maybe. You study different sites with different pH, so the water that site have different pH due to volcanic activity and so on. That is also the context.
The context is that the pH itself was used as a proxy to see how much the volcanic activity affects the site.
Okay.
Because even though you might see volcanic pumps in your meadow and you go and sample from within the meadow, the intensity of the vents might not change the pH as much.
But why do you think, because the Posidonia that grows in that site are here from many years, so what do you think that will have a difference? Because if you change quickly or drastically the pH from a Posidonia that grows usually at low pH to at high pH to low pH, okay, you can observe difference, but in that case, the Posidonia that are here have the term is adapted to this pH. So why do you expect a difference? For me, it's not so obvious.
Okay. So the idea is also for the publication specifically on the site that they have high productivity, Posidonia that are in more acidified conditions in Asia, and also greater below ground biomass. And this, since this below ground biomass is what is deposited afterwards to sediment, this is the biological link that links to sedimentation from the vents themselves. Paula? Paula disappeared.
She's here, but don't worry. Yes, go, Paula.
I think they have the same questions that the two previous, and it was more related on the biomass, Posidonia biomass, and the Posidonia coverage. And did you see some differences in the quality of this Posidonia on the leaves, for example? And then if there is a difference on the coverage, it cannot influence your results. It could be a positive correlated in a high pH or low pH, high PCO2. So do you have some idea about that, some value or some previous data that they show the differences in coverage?
Okay. So what I see here is two different questions. I'm going to ask to start with the first one. If Posidonia themselves have difference in their biology, we saw difference in the biology depending on the presence of the carbon dioxide vents. Is that correct?
Yeah,
Perfect.
this is the first question. Yeah, and then if this influenced the coverage on the sites.
Okay. So the idea is also what Nuri is studying actually right now is that the Posidonia itself has different epiphyte presence on its leaves, on its shoots, compared to the proximity to the site. This means that Posidonia that is very close to intense carbon dioxide vents have almost none epiphytes, while as we go further and further, we show more epiphytes. And Nuri also thought about it as a proxy of how much the vents can actually have an influence on the ecosystem where the core was sampled. So this was the first question. And then the second question was if we have a difference in the coverage of Posidonia in terms of the sampled cores. So the cores sampled were actually very small. They were like, this is about 30 centimeters diameter or something like that. And they were sampled in Posidonia oceanica meadows. I don't see, for me, with my critical thinking, I don't see how if I have a much bigger meadow and a relatively smaller meadow, how it will affect the sedimentation rates taken of one spot from within a meadow. This is what I know. It's not that they found like a Posidonia, a very small spot of Posidonia, and they were like, okay, I'm gonna take a core from here, and then they went to a great meadow. You understand what I mean?
Yeah, I understand. Thank you, Ioannis. And then I have another question that is more linked to your graph. Could you put again the graph where you have the isotope analysis in respect to the depth, the core depth?
This
Yeah.
Perfect.
Yeah, those one. And I saw in your first graph a decrease with, if I understand, there is the value of the 210 PB with the depth of the core, right?
Yes.
Yes. In your first graph on the left, you have a decrease with the stabilizations, and they go until 4. The two others are plus minus the same. This decrease on the first centimeters, yes, and then you have an increase. But as the two others are more deeper than the first one, I'm just wondering how you can interpret this increase on the value. If I just look at the red dots, for example, you have this decrease and then it's increased again.
So when you mention two others, you mean the two other values studied here or the two other graphs? This is what I didn't understand.
Yeah, on the one on the left, the
Okay.
centimeter depth, they finish at 4 gram per centimeter. That it should be the amount of sediments there is, right? Yeah. On the others, they go until 7 and 10.
Okay. Here and here. Perfect. Okay. Now I understand. Okay. And the question based on that is why this is
And
happening.
no, I'm asking if you have in fact a decrease in the 3 samples in until 4, and then you have an increase in the sample in the middle and the sample in the right. It's not
Perfect.
clear in the sample in the right, but it's clear in the sample in the middle. And I'm just asking why, and do you have
Yes.
an explanation on that?
Yes, yes. Okay. So the first idea here is that we have different actually depths measured because sometimes what we might have seen is very, very much core sediment and very little lectitudinal activity. So this limited the depth we could go in. And also the depth of the cores themselves was different. If I understand correctly, the question is if I just looked at the 4 grams per, on the 4 grams per square centimeter here and here, if, for example, I see a decrease here and then I see an increase, like this can limit the comparability of the figures themselves. Perfect.
Yeah.
So perfect. So this is why, for example, here, even though we can see a small decrease, like a decrease here, maybe a pattern of decrease here and here, then when we go deeper, we see actually more mixed sediment. Then we say, okay, we calculate the sedimentation rate, but we take into consideration that we see the mixed sediment. In here, it is true that we don't know what is happening below it, and I assume this could be a qualitative analysis assumption that in deeper layers we don't have mixing based on the profile we see of the core in general, and based on other cores of the same site maybe. It's very, this qualitative analysis doesn't have a specific way to do it. It's a bit more complicated.
Yeah, I imagine also because the core is.
It could break at some point in greater depths, and we could see mixed. But this was just the
Yeah.
results for us,
Yeah.
with the limitations.
Okay. Thank you very much, Ioannis, for your presentation.
Thank you.
Do we have last questions? No? We're all good?
Quick question, just for clarification. How many cores did you say was at each site?
The cores themselves have the sites themselves have different amount of sample cores. You can see here.
Okay, thanks. Perfect.
Okay. If you want, we can talk about
that's
this.
good.
Okay.
Yeah, no, I just wanted the.
Okay. Yeah, no, it's different. Yeah.
Appreciate it.
Okay, well, I think thank you.
Thank you, everyone.
So we will be back after the break. So we are going back live at a little break. Going back at 3:05, 3:10 to have Megan. Yes. Okay. So see you there. Paula will see you. No. no. Okay, so we are back for the last part of this session. So we are going to have Megan, and just at the end we will have Alexis. Ready? Yes. Okay, so Megan, do you have the time with you?
I'm good, Emma.
You're good? Okay. If everyone is ready, Paula, you are ready too? Yes, okay, perfect. So you can start. Okay, to add your slides, and here we go.
Perfect. Good afternoon, everyone. I'm Megan, and today I'll take you through my immersion project that I did this year on the effects of environmental change on Arctic benthic communities. This was done with Dr. Steve Como, and for my project, in amongst his bigger project on these effects of environmental changes on the Arctic benthic communities, I looked at creating a non-destructive methodology to measure the percentage cover and biomass of these benthic communities. So today we'll be going through just the general overlay of everything we'll be going through, just so you know what's to come. So to start with, as an introduction, why are we looking in the Arctic in the first place? So temperatures in the Arctic are increasing at twice the global average rate. In the graph we see here, it's just a graph that was depicted from different observation models. In order to depict temperature anomalies, in the darker colors is the Arctic, and the more faint is the global temperature anomalies over time, from 1950 to 2022. And as you can see, for Arctic temperatures, even the anomalies themselves have higher magnitudes. One of the biggest consequences of this increase in temperature is a decrease in sea ice cover. So over the last 30 years, there's been a 40% decrease of sea ice cover in the Arctic regions. This sea ice cover is also changing seasonally with earlier summer melting of the sea ice and later freezing of the sea ice. In terms of this temperature change, the water column in the Arctic Ocean is changing too in terms of temperature, salinity, pH, nutrients, and sedimentation within the water. One of the most affected regions in the Arctic are the coastal regions, and this is because erosion from the melt from the sea ice and the coastlines causes higher sedimentation in the coastal regions. So one way that we can look at the consequences of these changes is through Arctic benthic communities, and more specifically macroalgae. So macroalgae are large brown seaweeds, and they're found throughout the coasts of the Arctic Ocean. They're important foundation species that provide a habitat for many species and invertebrates. They provide food for Arctic food webs, and they are found along all the coasts of the Arctic, as I mentioned. So kelp control their growth and how they survive are controlled by temperature, ice cover, salinity, turbidity, nutrients, and the UV radiation within the water column. These are all different factors that we've mentioned before that are changing in the Arctic Ocean. So what literature has found so far on these macroalgal species in the Arctic, that the regional and species-specific changes are evident. So whether you're in the north or the south of the Arctic Ocean, and what species you're looking at, how they are tolerating these different changes. So understanding these changes in Arctic kelp communities is a way for us to understand the effects of the global climate changes. A question we can ask is how kelp are being studied in the Arctic today. So we have experimental methodologies, in situ, and models. So experimental models could look at how different effects of the water, such as temperature, light, or pH, are changing and how that affects the species, from their general physiology all the way to transcriptomics. We then also have in situ methodologies, which looks at the production, the coverage, and biomass estimates of the kelp in the region. And you can have destructive or non-destructive methodologies. So non-destructive would be things like photographic surveys of the algae, and more destructive ways the kelp are sampled by taking them out of the water column. We also have other things like measuring the production of the kelp or the metabolism of the kelp in situ as well. And a quick example of models that are produced, this study by Van Saan et al. They took the topography and the depths of the Arctic Ocean, and they related this to biomass of kelp in a way to kind of map the kelp in the Arctic. So now that we have these different studies and we know how it's done in the Arctic, for this specific study that we're doing today, I want to focus on a specific part of the Arctic Ocean, and specifically Kongsfjorden. So Kongsfjorden is a glacial inlet on the northwest coast of Svalbard, which is an island in the Arctic Ocean. It's about 79 degrees north. In this specific fjord, there's a rich history of research both in the water column and outside because of the research base that is there. And the marine benthic macroalgae in this region has been studied since 1832. So since then, 142 different macroalgal species have been identified in this region. However, the previous studies lacked quantitative data on the biomasses and the densities and the coverage of the specific kelp species that were found there. So now that we know this, we can go into the aims of the study that we'll be looking at today. So my aim was to develop a non-destructive methodology to analyze these benthic macroalgal communities. And then from this methodology, to test if it works, we wanted to compare the macroalgal distribution between two sample sites within the fjord that I just discussed before. And to answer our question on the effects of climate change on these macroalgal communities, we wanted to take our findings from the study and compare it with historic literature that's been produced on the macroalgal communities in Kongsfjorden. So in terms of our materials and methods, we know that we're in Kongsfjorden and we have two sample sites, Hans-Niset, more on the inner fjord, and Kongsfjord-Niset on the outer fjord. So Hans-Fjord-Niset is a moderately exposed shoreline. As you can see, it's facing the mouth of the fjord. So you have a lot of incoming Atlantic warmer waters that affect this site. And that's one of the reasons why it's studied quite often in literature that we'll see later on. A thing to note here is that it's steep. There's a steep gradient of incline from low to deeper depths. And temperature, light, and salinity is seasonal within the region. Then we have Kongsfjord-Niset, which is at the mouth of the fjord. Here we have a more gradual gradient, and it's a bit more rocky than the Hans-Fjord-Niset site. So Hans-Niset has a much more sediment composed site, whereas Kongsfjord-Niset has more rocks, and something we can look back later when we look at our results. So the next question is, what was our non-destructive methodology? How did we go about doing this? So we did video transects using a remote operated vehicle. So here there's a picture of what it looks like with a camera and propellers that you can use to do your video transects at the sites. So for each site, the ROV is placed into the water and you can send it whichever direction you want. So what we did is that we took the start and end coordinates of each of our transects at each site, so one transect per site. And this allowed us to get the distance that our ROV traveled. And what we tried to do is keep it parallel to the shoreline so that we were staying at a constant depth when we were looking with our video analysis. What we got was at Hans-Niset site, the one on the inner fjord, we had a total time of our video transect of 9 minutes and a total distance of about 490 meters. At Kongsfjord-Niset, we had a total time of 6 minutes and a total distance of 338 meters. Next, what we wanted to do now that we had our video footage is look at what species we found in them. So in the study, we focused on three main macroalgal species. They were Alaria esculenta, Saccharina latisma, and Laminaria digitata. So all these three species are in the class of brown algae. They're all overstory kelp, so this means in your kelp bed you have overstory species and understory species. So these three species are found above the kelp bed, so if you're looking at video analysis, they're good ones to choose because you can visualize them in your video transect. They're also perennial species, which means they're there throughout the year, and they're also common amongst all fjords, all sites that have been studied in the fjord. They're also dominant biomass contributors to macroalgal forests in the Arctic. And lastly, these three species in the bigger immersion project of this study are looking at different experiments with these three species. So we had available data on things like their lengths and different reactions that they have to changing temperatures and salinities and pH. The next thing we did from our video transect, so how are we going to do this? What we're going to look at first of all was to calibrate a field of view. This I'll explain a little bit more later because it's a bit in detail, but if you have questions, you can let me know. So what we did is we tried to measure the width of the field of view we were seeing in our video footage. And this allowed us to get an area that we were covering by our transects approximately, so what you're looking at throughout your video. Then what we wanted to do from each of these videos is to extract stills from the image that we could use to analyze. So this was done on VLC Media Player, a media player that I'm sure everyone knows. And the methodology towards it was that an image was extracted, a still image from the video footage was extracted every 9 seconds. So this prevented any overlapping of our images that we were going to analyze later. And we had different numbers of pictures that were extracted. From these pictures that were extracted, we wanted to look at percentage covers and counts of our three dominant species. So we used PhotoQuad, which is analysis that allows you to spawn 100 points onto your picture, and it allows you to work out the percentage cover, and that way you can work out the percentage cover throughout the transect. And then we wanted to look at counts. So counts were a little bit more tricky because some of the images are unclear. So images that are unclear are harder to see. We neglected and we only counted the species in the frames that we could. This allowed us to get the average number of species that we normalized to 1 square meter that we could use later for comparisons. Next, to do a biomass estimation, to take it a step further, what we did was get conversion factors that are available in literature that you can use from the height of your kelp and convert it into a fresh weight in grams. So this was a cool way from video transects to get quantitative data on our macroalgal species. So moving into our results, we can start with our two sites that we mentioned before, Hansneyset and Kongsfjordneset. Hansneyset was at the inner fjord, Kongsfjordneset at the outer fjord. The first thing just from the visual transects of what we saw was that at Kongsfjordneset, there was a mass, the kelp forest was dominated by Laeria silenta. So if I explain what we've seen in the graphs and what's happening here, we have Saccharina, Latisma, Laeria silenta, Laminaria digitata for our three spaces, and then we have other. So other included places where our points fell on the seabed, where the species couldn't be identified or wasn't our three species, or where the field of view didn't allow us to identify the species. So generally what we can see here between the two different things was the high amount of Laeria silenta in the comparison of the two sites, as well as no Laminaria digitata in Kongsfjordneset. Then the next thing we wanted to do to kind of do a statistical analysis is to take our counts. So we had our number of individuals per meter squared of our three kelp species at each of our sites. So in these box plots, we have the species at each of our sites. So we have Hansneyset, Kongsfjordneset for Laminaria, Saccharina, Latisma, and the same for each of the next species, as well as the number of individuals per meter squared. So to test significantly and to compare within the sites in terms of the three species and how their coverage or their numbers were associated, we saw no significant differences for Hansneyset between the three species, but we did find it for Kongsfjordneset for our three species. And then to do a comparison between the sites, I wanted to look at significant differences between Saccharina and Latisma's number of individuals at Hansneyset or Kongsfjordneset. And this was done for all three species, and we found significant differences between the two sites. Then our next step and our next question that I wanted to ask was to how we could compare what we had got from our video surveys to historic literature, and could we predict any changes using this new methodology. So what we did is we looked at two previous studies that were done at our Hansneyset site, the one that was in the more inner fjord. And at this site, previously between 1996 and 1998, Hopek did a study of the macroalgae coverage there. And then 10 years later, Barch et al. Did the same study, tried to replicate it in order to see changes in biomass, coverage, and number of individuals. And then we, of course, have our study. So if we want to look deeper into the comparisons of the three studies, the two previous ones were done by distracted sampling. A quadrat was put on the seafloor and the kelp were extracted and biomass estimates and numbers were figured out that way. And we, of course, have our ROV video transects. In terms of seasons that they were taken, we obviously have a lot more numbers of times that the kelp were sampled between the two ones, but our time of year is relatively the same, looking in spring and summertime. Then we have species diversity. So our two previous studies looked at all the taxa of macroalgae in the area, where we, of course, only had our three focus species. Then lastly, in terms of depth distribution, as I explained how we did our video transects, we were kind of limited to our 5 square meter line, whereas the other ones had a depth gradient between 0 and 30 meters depth was the one that was the deepest. So how did I get all this information to try and show our comparison? So firstly, for our three species, from the previous two studies, I was able to extract the fresh weights of the individual species per grams per meter squared of our three focus species from the two previous studies. Then I just extracted the 5 meter values from the two previous sites. So let's see what we found. So first of all, we have our years, our three different sampling time points, the one in the middle and our one. And we have the average fresh weight of our total. So this is like our three species put together. And the first thing that we can see here is that our results from our ROV survey are in the same order of magnitude as the distracted sampling site. So this means that maybe this methodology is something that can work and be comparable to more distracted methods. And then the next thing that we can see is that we can visualize some trends over time. But to look deeper into these trends, we wanted to look at each species individually and see what was happening. So here we again have our 3 time points and our 3 species, Saccharina, Laeria, Laminaria digitata, and the average fresh weight. So in this situation, we can see if we point out different trends, we can see an increase in Saccharina, an increase in Laeria, and a decrease in digitata over time. So these are general trends that we were visualizing. In terms of discussion, now that we know that we can compare it to previous literature and our 2 study sites, we can do our 2 study sites first. So through this non-destructive methodology, we were first able to observe general patterns of macroalgal coverage at each site, and we were able to compare the species compositions between the two sites. What we can see from literature, previous data in terms of our Hansen set site, all our 3 species were identified as dominant species within the site in previous literature at 5 meters depth. So we were kind of seeing what previous literature has already mentioned. At Kongsfjorden set, our one that was mostly dominated by Alaria esculenta, previous studies that we've done had found all of our 3 species at this depth. So the question that asked was like, why am I not seeing all of them in this percentage ratio? And looking specifically at Alaria esculenta in previous studies, specifically one done in 2009 in Kongsfjorden set, when they went to go study this region, they observed a barren ground. There was no macroalgal cover there. And they associated this to the fact that sea urchins had deteriorated the kelp site. So they saw no kelp species there at all and didn't identify any species. And what we know from literature is that these species, Alaria esculenta, are opportunistic species that are capable of large dispersals and are usually the first species to colonize a site after it's been deteriorated. So possibly what could have happened is either sea urchins or physical abrasion could have happened at the site that caused damage, and then Alaria esculenta came and populated the site, which we saw from our visual surveys. To really go over our discussion in terms of our comparison with previous data, what we saw is that through non-destructive methodology, we were able to produce results in the same order of magnitude as the destructive sampling methods, and we're able to observe patterns of increasing and decreasing biomasses over time. In terms of our 2 increasing species over time, we know from literature that these 3 species are considered species that have a optimum temperature range of 10 to 15 degrees Celsius. Because the Arctic Ocean, the maximum temperature is about 10 degrees Celsius. If there's an increase in temperature in the Arctic over time, it's predicted that these species will do well with increasing temperatures. So maybe what we're seeing here in the increase is them doing better in the warmer environments. In terms of the previous study by Barch et al. Between 2012 and 2014, they also saw general increases in the biomass of these 2 species in their study comparing it to the first one. Then lastly, for our decreasing Laminaria digitata, what we found was our decrease, but however, what we didn't include in our study was the depth range, whereas where Barch et al. Compared their study to the first study, they found that there was a 2.4-fold increase in Laminaria digitata in their sites, and they accounted this to a huge increase of the species at a shallower depth. So at 2.5 meters, there was an 8.2-fold increase of Laminaria digitata. So what they saw was a zonation shift of the species moving upwards to shallower depths, and this zonation change there accounted to the deterioration of the euphotic zone due to sedimentation. So you have increasing increasing ice melt that's entering into the water column that brings sedimentation, which kind of decreases your zone in the water column that gets light. So for this reason, because kelp primary producers, they move up shallower so that they can produce better. So in our study, we could have concluded that yes, there's decreasing Laminaria digitata, and that's what we see. But meanwhile, because we didn't look at the whole depth range, we kind of missed what happened in the whole community. And this brings us to our limitations and perspectives in the study. Okay. So we had our restriction with the 5 meters. We also had some limitations with our ROV in terms of the scaling and how we measured it. It didn't have a GPS on board. Obviously, underwater makes it tricky. Lasers are usually put on ROVs that you can see in the picture down there to scale what you see in your image. This we didn't have and had to make other plans around it. We were able to use conversion factors to get from heights to fresh weights. However, if you look at kelp, their age can also determine their biomass, and that's something we didn't consider and wasn't put into the study. And then an idea to push the boundaries of the methodology could be to incorporate different conversion factors that look at different aspects of the kelp as temperatures and climate changes. So in conclusion, we can say despite our limitations of the video survey, we were able to get results on the percentage covers and changes over time of our kelps. We were also able to use this non-destructive methodology at a low scale, and it was important to consider this because if we need to monitor and map the changes that are happening in the Arctic Ocean at the moment, methodologies to have a baseline study of the species is important. So thank you to everyone, and thank you you guys. So.
Well, thank you again. I think you can check the screen. There is like so many people saying I do an amazing job. I'm just passing on. There is Kylian. There is of course like Camille also. You have like Ioannis watching from the other side. Emma, Alexandra, Martha. Okay, guys, do you have any questions to start with or Megan? Yes, Max.
Yeah, so it's I really like some of the terminology you're using as like describing these as kelp forests, kind of having these canopy species and then these kind of lower macroalgae as well. It was also interesting looking at that succession rate of the it starts with the A, it was the orange colored.
Yeah, Alleria esculenta.
Alleria esculenta,
Yeah.
that it was so much more prolific than the other ones.
Mm-hmm.
Now, when we look into kind of the timing of climate change, is there a more preferable macroalgae to kind of maybe push for its survivable compared to the others, the kind of like as its benefits due to the different trophic webs and whatnot?
Yeah.
I know like from like working in the forest, if you're looking at climate change going on there's certain trees you want to get rid of and certain trees you want to help kind of like keep more of. Is there a certain case with that with these macroalgae?
For sure, because like in total 142 macroalgae has been identified in the Arctic already. A lot of them have an Atlantic origin, like they're from Atlantic water, so they already have this higher temperature range as it is. So borealization is this thing of the macroalgae in the Atlantic Ocean moving upwards as the waters get warmer, so they move up to this. And there's other species that are endemic to the Arctic that have a smaller temperature range than say the others. So kind of the ideas in literature that have been put forward is that some species will benefit from these changes and others will suffer, and that will change the whole ecosystem, whether it'll be a tipping point or if it'll make the Arctic more productive. It still changes. It's like, what's the question behind it? But it's definitely species specific and how each species can tolerate the changes that are happening.
Yeah, so maybe are like the ones that are endemic there least flexible to that change, and some of these other like Atlantic kelps, are they kind of becoming more since they're migrating through there, are they kind of taking over those niches then?
Yeah, 100%. And studies that I've seen, so one of the endemic species that's quite well known is also Laminaria brown kelp species. They've been seen less and less in the Arctic, whereas more of these like Saccharina luteismus, their presence are getting higher and higher. So already changes in just observations of these kelp species has been seen. So
has there been like a notice on like a trophic cascade level from that?
I think specifically in the Arctic, in terms of macroalgae and their role in the food web, it's very understudied at the moment. Mm-hmm. So understanding food, I think the first step is understanding the macroalgae and their relation to the food webs in the Arctic.
Yeah. Cool. Right.
So before moving on to you, we have a question online. So yes, we have like everyone saying great presentation, lovely photos. How much time was spent gathering data as opposed to analyzing the data, and are there plans to do a following study in the same area in the near future?
Hello, my cousin. Thank you for the question. That's really cool. So the video analysis took a lot longer time than it did for the 9 minutes in the Arctic. I guess if you consider like the preparation for the field work, making sure all the equipment works, that was maybe a lot of time spent. But in terms of analyzing the video footage, especially because of the limitations that we had on the like apparatus, like lasers itself, that took a very long time. And I hope that for next year that Steve will go back to the Arctic and we'll do this again and do it in a way that makes more sense for the Arctic.
Well, thank you for this question. I think now we can open to the jury. Paola, do you want to start first?
Hi, many thanks. It was a very nice presentation and I suppose also a very nice trip. I have a question regarding the differences that we can probably found in the different species in respect to the depth. Mm-hmm. You analyzed one depth, 5 meters depth, and you saw differences in the history of those species. Do you think that you have the same? What is your feeling? It's really your feeling, but what could be Are those difference the same at the different depth? What you know, what you can think about that?
Yeah, I would definitely say that I don't think it's the same at every depth. I think it definitely varies, just like especially depending because at each site there's so many macroalgal species and each of them kind of adapt at their own kind of species specific zone. So even that 2.5% increase that we saw that was eightfold to the 10 years before, that was only in the 2.5 meter zone. It wasn't in the 5 meter zone. So I think not just sites or not just regions of the Arctic, but even just the depth gradient on the coastline has changes depending on the different environmental factors.
Okay, thank you. It was my only questions. It was very nice presentation. Thank you so much.
Thank you.
Yeah, I think continue. Thanks also for the nice and interesting presentation. I have a few questions actually. So you use published data to estimate the fresh rate of your film data.
Yeah.
How confident are you that those values that I think the paper was published 10 and 30 years ago, that this relationship between height and plant rate is still maintained?
Well, if I go to those specific conversion factors, it wasn't taken from the studies before. So for each of my 3 species that I looked at, there's different experiments and data specifically from Camille where they're taking the samples out, doing the non-destructive and doing the heights to weight ratios. So for each species, some of the references that I got it from these weight ratios that they've done it through their experiments of like height to mass, and you get your linear relationship to get your conversion factor. So in terms of confidence, I think there is a sense of confidence, but I think because you in this environment in the cult and it's so different to an experiment, it's hard to, like I think you can be confident because they do a lot of experiments over time and you have this, it's kind of, when I looked at different papers that had the different height to weight things, the values weren't very different. Even between the species, like some of the values are not that different,
And then the other thing is, so you did a 480 and 360 meter transect, and the other studies used a quadrant, right?
Yeah.
So how do you extract the quadrant size from your video footage to be able to compare?
Yeah, so from the 2 previous studies, they had their quadrats, and their quadrats were either 0.5 or like 0.25 square meters of opening over the coverage, not very big. And then it was quite easy for them to normalize that. Whereas because I didn't have the scaling reference and I just had my image of size, this is where it got a bit sticky because of all that different analysis. But if you look at the image here, so this is just the photo card that was used for percentage coverage. So when you look at the image here, there's normally, maybe on this picture there's one. Okay, so on the drone it gives you different information of its depth difference. So it's not reading the actual depth, it's just reading from when you started to when it goes down, you have like this depth difference and things. So what I did to even measure the field of view that I was seeing in my extracted images was before we started each transect, we put a 1 square meter quadrat on the seafloor, like on the kelp where it was possible to kind of do it. And we moved the ROV from the seafloor upwards. And from that, we were able to get, like, if I'm reading this depth difference on the screen, and I know that that was my measuring scale at that depth difference, then what I'm looking at later, I can scale it to my 1 square meter.
Okay, that makes sense. And I have, if I can, two questions. Do you think that there might be some AI approaches that could help you to identify? That may help to, especially on very long transect, to identify.
For sure. I've seen studies that are already using like the light and the different kind of reflection in the camera that it's setting to identify the species like straight away. Less so in the Arctic, like in places like aquaculture farms where they're testing it, everything's a lot more stable and in line and easier to see. Whereas places like this, I think things like AI where it can identify from the video footage, I think that will be the next step. Even like photogrammetry where you take your video and you can do a whole analysis of that. Yeah.
I have one last question. You mentioned that in some areas there are a lot of sea urchins. And so what I didn't get is are the sea urchins sort of eradicating a full-grown kelp forest, or is it more that they attack the newly born kelps and then there's no chance of kelp forest to grow?
For me, it's in the Arctic specifically, I'm not too sure because sea urchins weren't that prevalent, say, when Hop et al. Did their first study. Like, they weren't seen in the Arctic, only recently they are. But I imagine that if they come into the site, they would destroy both. I don't think they'd eat away a whole kelp forest in one go like that, but I think it affects all the life stages depending on the season where they're feeding on the kelp. But other things like physical abrasions, like because it's a glacial forge, you have a lot of icebergs that come through. So ice scoring on the coastal zone is also something that happens quite a lot, which is something else that could also be deteriorating the kelps with the seasons of the coast.
Okay, cool. Thanks, Al.
Thank you.
Thank you very much. And it's not very clear for me if you made a calibration between your picture and the real something during your training period.
Mm-hmm.
Did you make a real calibration or
Yeah,
just
it was from that thing that I explained before, the calibration of the actual camera, no, just in terms of field of view. Because in literature, so as we were like preparing to go, there's different things that you have to look at, like the lens curvature and the reflection of the water. Those things they weren't considered really before our study, before we left. So I used that idea of the 1 square meter quadrat with our depth reading that we were seeing on the screens. Every time it was extracted, it gave a depth, and I related that to where we had a scalable thing in the image to kind of calibrate between the two.
Okay, so this in the same idea, you compare your study with 2 older study.
Mm-hmm.
What do you think? Because they use very different way to measure the biomass on the floor.
Yes,
So how are you confident and are you in this inter-comparison without intercalibration of the method?
Yeah, I think that's somewhere where the limitations existed in the literature. But in those 2 previous studies, they did the destructive sampling where they took the kelp out, measured the wet weight, so the fresh weight that they acknowledged, and then they dry it and they get the dry weight and they do the whole comparison. So in the way of me using the conversion factors of the species that is known to get the height to the fresh weight, that kind of gave me confidence that even though it's a different method, we're still using these factors that are similar to what they were seeing in their study. But I think even more so things like the height of the kelp. So that I couldn't measure the height of the kelp in the video footage. So from destructive sampling that Steve had done before for his mesocosm experiments, they had the heights of our species that we collected from the site. So the average of those heights we used for our average of kelps. So like small things like that in terms of the methodology and how it's applied to compare it to non-destructive, I think that there's a few gaps that possibly can be corrected if you use the right approach.
Because your approach allowed you to have all the dimension of the macrologic.
Mm-hmm.
It will give you the size and when you analyze this picture, you will have all the.
It's more like from the count, so you would say you count how many of each species,
okay.
And there's that many, and there are this average height, and then you do your conversion factor to get the fresh weight of each individual.
Okay. And what happens when there is no macrology? So you draw an arrive, there is some place where there is macrology, and although there is just groundwork, it's quite similar with brown macrology. How you react your software, because you have a software that makes the analysis.
Yeah, so it's just like photoperiod, which is just something where you overlay, so it's kind of almost like physically putting a quadrat on your picture to do percentage cover. So it doesn't really tell you. It's more so like if I had to spawn these for the percentage cover, and I know it's on Alaria esculenta, you can select those points and you can assign it to the species. So I had the choice to what it was being assigned.
So it's not made automatically, you do the job.
Yeah, I do the job.
Yeah.
I hope eventually there'll be an automatic process. I don't have to do the job.
I am at the next step of the system. Okay.
Okay. Yeah.
Okay, well, thank you again. I think we have just one last on YouTube. I'm sorry, we have one question just appeared from Petra, who is asking if there is any plans, if you know, perhaps to collaborate with pharma industry or commercial industry in order to get fundings for future experiments.
It's my sister. Can
Ah,
you
that's your sister. Oh, the family is here. Nice.
I think for sure in terms of pharma industry and commercial industry, there is a link. Specifically next year with my internship, that will look at kelp species and active compounds that are extracted from kelp species. So a way to look at biomasses in the field of the farm or whatever could be a cool way to link the two, and a way to get funding for the research so you can get more advanced like R&D equipment.
Well, thank you again. I think we are in lots of online thing. Well done. Thank you again. Thank you. Okay, moving on with Alexis. So you can change it. So normally you just need to go from up and down. Yeah. Okay, so we have now the last presentation. You can see on the screen what's happening. So you're going to. Okay, so you're ready for your 15 minutes? Yeah. Okay. Well, let's go.
So hi everyone, thank you for being here for the last presentation of the session. My name is Alexis, and I will try to defend my immersion project about the study of blue carbon accounting and sequestration models. So first, a quick overview of what we will present during this presentation. First, we will have a small introduction on the main study. Then the different problems that raised on this study, the hypothesis, and the two different objectives of this study. Then the methodology used to ensure this hypothesis and the results obtained. And lastly, we will have a discussion about the results we have and the conclusion and perspective and limitations of this study will be conducted. So first, some kind of environment about my internship and study. I did my internship in the startup Blue Leaf Conservation. So the startup has been created 1 year ago, more than 1 year ago now, by two former students of MARRES, Ioannis and Frederic. So Blue Leaf tried to implement some conservation projects about blue carbon in the blue carbon ecosystems. They pose themselves as a project access facilitator. So they facilitate the implementation of the blue carbon projects between private and public sectors, notably through the sale of carbon credits. So first, a small introduction about the blue carbon. Blue carbon is refers to the carbon sequestered by the world coastal oceans ecosystem, so the mangroves, the salt marshes, seagrass beds, and we could also consider the macroalgae, such as the kelp forests. The carbon is stored by the living organisms in the plants as they grow, or also in the sediments as they accumulate and bury in the soil. Examining the financial and economical aspects of developing science-based projects and models, of course, will allow us to highlight mitigation and adaptation benefits of conserving and restoring the blue carbon resources. And then that's why the blue carbon is the ideal case study for ecological and political economy of the climate change. Then we have two problems that can be raised from this introduction. The first one is some political, social, and scientific issues that we have in blue carbon projects. In terms of economic problems, issues that we have, which are the most important in the blue carbon projects, we can say that it's not a viable way to finance blue carbon projects by the carbon credit financing. Why? That's because the cost of carbon credits is very high, so not all project owners can afford them. Basically, to have carbon credits, you need to certify it and then monitor the blue carbon ecosystems, and it costs a lot. So that's why it's not a viable way to finance the blue carbon projects. Then a political issue that can be raised in the blue carbon projects is basically the land where you have the blue carbon projects are owned by governments or local communities also. And claims of ownership, lease of these lands, and use rights of these lands can overlap sometimes each other. Let's take an example. Let's say you guys, you have a yacht that you anchor a lot of always in the summer in the Bay of Cannes, but suddenly you have some project restoration about seagrass that occurs in the Bay of Cannes, and you cannot anchor anymore your yacht. You will be mad, of course, and will protest against this project. This is why we have some political issues to manage between the tourists, the public, and the private sectors as well. In terms of social issues, there is some kind of lack of confidence from the local communities for the blue carbon projects. For example, there is some blue carbon projects that put aside the local communities from the area, so the blue carbon ecosystems, just to implement their own projects. And it resulted that the restoration activities were not very effective on this ecosystem. And at the beginning, the local communities used this ecosystem in a sustainable way. That's why sometimes you have a lack of confidence coming from the local communities on these blue carbon projects. And last but not least, the scientific issues on the blue carbon projects. Basically, it's the basis of the blue carbon project, the scientific way, how to restore and protect these ecosystems, how to assess the carbon sequestration in stocks. And this can be or try to be overcome by the scientific way for the blue carbon projects. Then second problem we can raise is that the carbon credits are not attractive enough. You will see why in the discussion parts. So we can have some hypotheses on this. Is a universal model for the blue carbon accounting and sequestration model can exist. So the purpose of this study is to try to make a proposal for an initiative universal and scalable model for the blue carbon accounting and sequestration models. The two objectives of the study. The first one will be a big literature review about the blue carbon. So try to research the limitations and the problems of these existing models. And the second one will be to try to propose some new ideas, some new perspective for a new model or draft for the blue carbon accounting and sequestration models. Methodology used during this study, basically the literature review will be on the carbon projects, on the methodology for conservation and monitoring them, and on the blue carbon market, so how to finance these blue carbon projects, carbon credits, and so on. We had also some meetings and appointments during this study. So first with the startup team, with potential investors on the startup, and with the IPE, which is Incubator Paca Est in French, which is basically a company that tries to help startups to evolve in society and to put in contact other startups with each other. So for the literature review, I use online databases, so such as Google Scholar, Elsevier, ResearchGate, Academia, Plus, which means for Public Library of Science, Percy, and Science Direct. It was all for the literature review. And for the meetings and the appointments, it was on-site or online meetings using the software Google Meet. So basically, it was just for a bit on my work with my team, so Yann and Frédéric, about news on my work, and also some small presentations that I did for investors about the blue carbon. And we also had some meetings on site, so on some co-worker space in Antipolis, for example. We also had the chance to meet some blue angels, so investors for the startup. So So the travels were made by train or by car mainly. And also the meeting with the IPE, so the Activator S, to put in contact all the startups that are present in this Activator S IPE. Now let's move into the results. The first results I would like to show you is something that I made myself, which is the emission reduction calculator. So this emissions reduction calculator was made on the Microsoft Excel, the software, and it's based on the low carbon label methodology, donc label à carbone en français, in French, which is a French label for certification of carbon credits. And this emission reduction calculator allows you to calculate the CO2 emissions reduction generated by a blue carbon project. So the layout and the method to code in Excel was taken from the BlueCam model, which is an Australian model. But the methodology, the formula used, are issued by the low carbon label methodology. So first, this is the different inputs that are necessary for the operation of the calculator. So basically, you enter the duration of your project in years, the total area of your seagrass beds or your area of your blue carbon projects in hectares. Then you have the carbon stock in your area in tons of carbon per hectare. Then you have the annual rates of progression of your ecosystem in percentage, the decomposition rates of in percentage also, and the last one is a discount made in terms of uncertainty of carbon emissions that are calculated on scientific models. Once you have entered all this data, you obtain this graph. So basically this graph, in the y-axis you have the percentage of emission reduction in CO2, and in the x-axis you have all the years different years. So it allows you to see each year's the percentage of CO2 emissions that you have reduced thanks to your blue carbon project. And you also have, right under this graph, all the details of each year for the total carbon CO2 emission reduction. The second result I would like to show you is a different way to monitor the blue carbon ecosystem, retrieved from the literature review. So this is a different methods for monitoring. I divided them into two different parts. The first one is the aerial methods, and the second one are the underwater methods. So the first one is the aerial one. First, you have the orthophotography. So under each pictures, you have four different contents. The first one is the logistic. The second one is accuracy. The third one is the resolution, and the last one is the cost. So red means bad, and green means good. So the first one is orthophotography. Orthophotography is basically the assembly of a lot of images or pictures in order to obtain one picture of a good resolution with high resolution. Second methodology to monitor is the satellite imagery. So I'm pretty sure you all know that. It's easy to access. The logistics is very easy. The costs are very low. And it allows us to see some kind of evolutions over time, such as here for mangroves. You can see the degradation evolution over time. And the last methodology for monitoring of aerial method are the LiDAR drone. So basically, LiDAR drone are drones that emit lots of lasers on the ecosystems in total different directions, and it allows us to measure by telemetry all the different altitudes of the ecosystem. Next one is the underwater monitoring methodology. First, you have the photogrammetry. Here is of the sequence beds of Posidonia oceanica. Basically, this is the same for the orthophotography. You take a lot of pictures in order to obtain one high-resolution picture. Then you have the DIVA method, which is a French method. And this one, it means acoustic vertical inflection deviation. And it allows us to have the position and the response by an ecosensor here. So you have the GPS position of each area you are mapping. And the ecosensor allows us to have to see if you have some Posidonia or you have some sand at this place. This method is not really accurate because you cannot already make the difference between Posidonia and rocks. That's why it's not very used for the moment. Next one is the photoperiod-like. It's a methodology created by Chlorella, a French company. Basically, just a boat, a platform with two cameras underwater, with a GPS on the boat, and it allows you to have precise mapping of the area with the GPS points, and you could also have some photogrammetry thanks to the two underwater cameras. Last one is the D100. So basically, D100 use acoustic telemetry, and the diver will just position some different beacons all around the seagrass bed to map them. So each beacon will have GPS points, and at the end, you can have some pictures where the seagrass bed is delimited. Now let's move to the discussion part. So first problem I retrieved in the literature is the problem in the monitoring of the blue carbon ecosystem. First one is the problem with access and logistic way. You have to be in physics to monitor the blue carbon ecosystems to have a better monitoring. And you know that the blue carbon ecosystems, you have no road, you have no specific infrastructure made to access to these ecosystems. So this unique characteristics requires specific targeted research and management strategies in order to assess and monitor the states of the blue carbon ecosystems. Last problem in the monitoring of these blue carbon ecosystems is about ecosystem conservation. You know that most of the world coastal ecosystem, they are under protection and regulation framework. And so you have to take into consideration this regulation and these laws in order to do your monitoring, such as, for example, MPAs or national parks, or also some restricted fishing area. So you have to accept this regulation and laws, and try to avoid these problems in order to do your monitoring for the blue carbon ecosystems. Next problem I figured out in my study is the problem in the meaning of the model. We know that all the existing models only focus on the carbon emission. That means that how this blue carbon ecosystem remove CO2 emission from the atmosphere. Why do we only focus on this carbon emission? I will come back later in the third part. And we also know that these models, they are not 100% accurate. We have most of this model, if not all, they have uncertainties in the calculation of carbon emission avoided in the atmosphere. And these models should not be seen as reliable, to represent the avoided CO2 emissions in the world. It should be acceptable to have uncertainty, since it's almost impossible for us to assess the global emissions of global companies in the world I mean, it's almost impossible to assess the CO2 emissions of all your laptops or phones. So it should be acceptable to have some incentives on our models to assess the CO2 emissions of blue carbon ecosystems. And then I thought about another way to improve these models. So just not focus on the carbon emissions, but why don't we take into account the ecosystem services that are provided by the blue carbon ecosystem? Why don't we make this as a new currency, just as the carbon credits? I mean, we know how to define them, we know how to demonstrate them, we know how to quantify them also. So let's make it as a currency, and blue carbon offsets on the voluntary market will then become more attractive to companies, and people try to be better seen on the social responsibility on the environment. But we'll come back on the custom services later. Next one is about carbon credits. And I saw that in the literature there is some kind of fear about carbon credits. What I mean by that is that they're not attractive. It's this market, blue carbon markets, it's still in its infancy, and few people are they have to be the precursors of these new blue carbon markets. And some obstacles that I found in the literature is additionality and leakage. So additionality defines the fact that actions and protection measures would not be possible or different without the sale of carbon credits. And leakage means that the degradation of the ecosystem, which is prevented by the actions and conservation measures taken, are going to be relocated in another place than the original place protected by the actions. Another obstacle to carbon credits would be the direct visibility and the direct return on investments that carbon credits about blue carbon ecosystem make. I mean that by that it takes a lot of time to blue carbon action and protection measures to have a direct visibility, to have a direct return on investment. It can take some decades and decades and decades to have concrete visual aspects of reduction of emissions of CO2 on the ecosystem. And that's why you should have some better visibility on this. That's why some people prefer to turn to renewable energy, for example, because on that you have some more direct visibility. It's faster and it allows greater return on investment than the carbon credits about blue carbon ecosystems. Now, let's move to the conclusion. So, blue carbon is not only a common pool resource of interest to governments and local communities, and the resource managers will also a commercial activity that represents an important, let's say, carbon sequestration is not easily valued, and accounting are not easily valued by models, but this can lead to opportunities and innovation thanks to the models that exist already. Although these models, they are imperfect, we know that, but they attempt to facilitate access to carbon projects, notably through the sale of the financing of these projects, notably through the sale of carbon credits. And then, therefore, we can ask ourselves for some perspective and limitations on this.
You are out of time.
Yeah. So this is the last slide. So models are an effective tool. We know that. We know that they are an effective tools, and then can be used. This will try to add some ideas to have some effective commercialization on these models to improve the health and resilience of the blue carbon ecosystem and the communities. And consuming the ecosystem services as a currency to add some values about the models, there are tons and tons of ecosystem services. So how do we choose which kind of ecosystem services we focus on which criteria we do that? So that's why we need some in-situ measurements to see if this initiative is applicable or not on in-situ measurements and if it is necessary to implement it. So thank you for your attention, and now it's the question time. I will be happy to answer questions.
Well, thank you, Alexis. I'm turning again for one last time. What do you? Any questions? Yes, go back.
Yeah, I think, this sort of work is super important going into the future. How do we kind of put a metric to our emissions, especially in blue carbon? It's really hard to do because it's, there's not an exact device out there that you can use to scale it with. I'm not sure if you know about like biodiversity credits or whatnot, but I was just curious if you looked into how developments, they'll kind of, they will like develop an area and then they will like save a part of forest or sea to kind of offset their emissions or their developments. Was that kind of something that, I guess, what are your perspectives in that manner? Is that kind of maybe like a tool that could be used in kind of what you were studying here?
So basically you're saying that these tools can be used to more protect ecosystem services?
Yeah, like biodiversity credits, or how what are ways to put a metric to our developments or emissions.
That's why I thought about in my study that let's not focus on the carbon credits to finance the carbon projects, because it's 100% accurate how it's measured, and then let's just take into account all the services that are provided by the carbon ecosystem, such as like let's say mangroves that will protect from erosion, from a tsunami. Let's say that this can put a value on this, and then you can more sell this let's say new biodiversity credits instead of just focusing on the carbon credits.
Yeah, totally. Because you can tear down a bunch of mangroves to build a hotel on the beach, but then you go and I don't know, preserve a bunch of trees in the Serengeti. You're not really kind of doing a equal trade there.
Yeah, exactly.
Interesting.
Anything else? No? Okay, so I'm turning now to you. Then you want to start?
Thank you very much. On one of your slides, you show that you can reduce or save in 10 years more or less 1% of CO2. For this slide 10 or something like that.
It's on this calculator.
Yes.
So just this graph, it's just an example of some random data taken in this project.
Okay.
That's not very.
I changed my question. Why random data?
It was just a trial. This calculator has not been tested for real projects. So just to test if this was working. So yeah, it's not very reliable data we can put outside to make some assumption on the reduction of CO2 emissions.
Okay, and so I am an investor. I am very interested by your project, but I don't understand how many CO2 I will save in 10 years. So can you give me some few key numbers, because I have no idea. Just what I see is 0.9, so it's for me very, very low.
It depends if it's, I've showed that, but under this you have all the details of each year your carbon emission reduction. So let's say your basis was, let's say, 1,000 tons of CO2. 1% is already 10 tons of CO2.
1% is 1%.
Yeah, but that's already a lot to avoid.
It's depends if you look relative or okay. I understand what you want to say, but in average, if you it's not clear for me, but if you try to don't you have a physical example of a project, what you realize or what the startup realize to say, okay, to this company we save 10 tons or 20 tons or?
No, this was just some kind of prototype I made based on the methodology. We did not apply it since it's just a prototype on real projects that are used already. I'm sorry.
Okay. No, it's clear.
Follow-up question, because I also question. So here I don't really understand. So did you enter the values for each of the cases, or did you enter the
All the
you
values
read
that are,
and the
yeah.
total area and then everything else calculated?
No, you have to ensure this by yourself.
Okay, that's for the startup or that's for the
No, the
company?
project owners.
Sorry?
The project owners that want to know apply for carbon credits emission. They have to put the data they have calculated thanks to monitoring of the carbon ecosystems.
And who is doing this monitoring? That's just my question. How usable is it for? If I want to start a project, I have no idea what about the blue carbon or something. You give me this Excel blue sheet.
First, you have to make some proposal for your blue carbon projects to monitor, to assess the degradation of your ecosystem, the carbon stock also that's photos to have like the if I can. So basically, in this, you have your baseline project. Baseline project is like the projects of the area which stand if you don't put some actions to reduce your carbon emissions. So at the end, we have your carbon stock. And this is the carbon stock without actions to protect the area. On the other hand, you have your project scenario. And this, basically the same as the baseline project, but at this you add all the actions and protection measures that are made. And at the end, we have a different carbon stock, which will be either increased or decreased, which stands for all the action protection that are taken. And then once you have all this data, you just put this in the calculator and you will have your graph at the end.
Why do I need this table then? If you have a carbon stock in the baseline project, the project scenario, and have a carbon stock, if I just take the delta, then I have the reduction or the increase. So why do I have to go back to the sheet?
Because this is just for you just have that values. You won't have the precise amounts of carbon emission that you reduce. Basically, you just have the carbon stock. You won't have the reduction of emission you made.
Okay. The second comment I have is more a perception comment, because here you write it's a reduction calculator. What I see is an increase. So I would suggest to just flip over the thing that it's really a decrease.
It's just,
It's just
understand what you say.
Yeah, I have a question. Just maybe a more general question. You made a big analysis of this sector to see finally the weakness, the strengths, etc. It's more or less the SWOT that you did. So for you and for the company you work with, what is for you the next step? What is the main point or the main problem and the next, not you speak about a lot of things, but what is the main problem and maybe the next step to try to reduce this problem?
So for me, the main problem in the blue carbon market and more generally in the blue carbon projects is the access to the blue carbon projects. Today, it's very complicated to be able to make blue carbon projects. First, because of economic, it's very hard to have carbon credit emission because of its cost. And so it would be, you have to pass through different organizations to certify your carbon credit, to monitor. So it's very complicated for small projects who do not have a lot of money to allow to do these actions. So basically, next step would be the simplification of this process. You don't have to go there, to make a small carbon project, but thanks to Blueleaf, for example, you will just contact one company that will provide you, for example, this kind of Excel sheet or calculation. They will provide some package, let's say, to monitor, to assess your carbon stock, to certify your carbon credits, to sell them also, and then to provide you the money to fund your carbon projects, blue carbon projects.
Clear. Thank you.
Yeah, I have a few other questions. First, I wanted to thank you for your honest assessment of the blue carbon field, because often when you hear presentations about blue carbon, everything is perfect, and so we have to go. It's one of the first presentations where I see problems. That's really interesting. I had a question on your second part of the results, where you showed all the different means to survey the blue carbon sequestration. Two questions here. One is, what were the thresholds for you to assess it from 1 red dot, 3 orange, green dots, 1 or 2 orange, and 5 yellow, or whatever?
It was a personal perspective perspective from the social review I made about this. So basically, for when I put a red dots, it's when you have to have some, let's say, technological way to do that. You have to hire some people to do this assessment on field, on site. So a red dot means you have to move yourself to the area to make the assessment. You have to hire some person to make this assessment, and you have to use some technological way to make this assessment. So basically, for the photography, you need to have a person take the pictures, a lot of pictures. You have to have discussion. You have to use drones or high-precision camera to make it, and then to assemble all the pictures into one pictures. That's why I put the red dots. For the drone also, you have to hire a person that can, let's say, use the data drone. You have to go to the area, and at contrary, you have the satellite imagery. I put green because it's easy to access online. You can access online with no cost, almost no cost. You can use it with your laptop and computer by home. You have to go on the site to do the assessment measurements.
I got sort of the thing. I was just wondering if you have something precise where you determine the resolution is red, orange, green, or something. Because if you go to the next slide, that's it's the logistic between your photo cell, that is just a camera on a boat, and then you have the D100 where you have a diver that has to put some beacons, and then you have to image this with a sophisticated GPS system.
This one is used like from 10 years ago, 20 years ago.
Yeah, I don't know, but it looks for me logistically more complicated, and that's why I sort of wondered. So I think it would be good if you would have some thresholds or something that sort of make work. At the end, what I didn't understand is what would you suggest is the best methodology to survey Posidonia meadows, for example?
For Posidonia meadows, I didn't look at the best way, but I would say that in terms of cost, logistic, accuracy, and resolution, the best way would be like some kind of combination methodology. Basically, I would say satellite imagery, for example, to see an evolution over time of the Posidonia meadows, to see if you have some degradation, and so on. The best way also would be some GIS software, where you can map very precisely the sequence with the use also of the photoperiod-like, which allows you to see with a very high resolution the different areas where you have some spots or Posidonia spots.
On the other screen, do you think that this might be a feasible approach, especially in some shallow water?
No, because you have some uncertainty on this one. You have the waves that can can't figure out the distinction between the Posidonia and the sand, for example. Like you can have some turbidity or so that will not allow you to have some good visualization of the Posidonia meadow. So yeah, that's why we need to combine all this methodology.
Okay, thanks.
Okay, perfect. I think we can, you have another question there? Okay. Okay, so I'm asking then to Paola.
Hi, Alexis. Thank you very much for your presentation. Again, most of the questions you answered them, but I still have two. The first one is still on your calculator, and I would like to have two. First of all, I would like really to understand what does it mean about regression of the herbier dans la zone de projet. Why you have to put this value, and this is this value that could be changed in respect to the project.
Okay, so this means so the annual rates of progression of here for the seagrass bed, which means that every year you have to put a value that say every year our seagrass beds will regress of this percent if we don't take into account the actions. It will allow us.
And how you evaluate? Sorry, this value by monitoring. So by the decrease that have been observed in the past, I suppose by a constant rate.
By constant monitoring and constant rate, yes, exactly.
Okay, and there is not could be, if we think about climate change and blah blah blah, some differences in this rate. Does this rate is accurate enough? Do we have enough information today to have really a rate to estimate that it's constant in the next year?
This kind of projects, so blue carbon projects, they need to be assessed again it depends, every 5 years or every 10 years, in order to see if we have some changes in this kind of data, for example.
Okay. So every 5 years you state if we took, yeah. Okay, it's more clear now. And on the same, do you hear me well? Yeah. On the same table, I would like, on the same calculator, I would like to know if we can. Do you think that you can sell this calculator, or you can use this calculator for something else? That the Posidonia meadows, do you think that it could be used for mangroves or something else that the seagrass?
Yeah, of course. This is one of the question I answered to got earlier. This is some kind of package that, for example, a company that wants to protect blue carbon ecosystem can sell in order to facilitate the access of blue carbon projects to blue carbon projects owners. So this can be within the package. Basically, it's used already in an Australian model, which assess I think it's about seagrass beds, but for those terra, so in Australia. It's called the Blue Cam, so Blue Calculator Accounting Model. And they sell this kind of Excel sheets, for example, to project owners that want to apply for carbon credit emissions. So yeah, you can sell this kind of Excel sheet, yeah, of course.
Yeah, and so try to sell me your calculator and why yours could be more efficient than another one or the one from Terra.
Basically, this one is made for seagrass beds. You have no French calculator existing. No one has created a calculator in France. And it's very important to we know that Mediterranean Sea is one of the most threatened sea in the world. So I think it's important to have some projects to avoid this kind of destruction. And this is why this calculator has been made for you to allow to create projects to avoid this destruction on the Med Sea. And it's really easy to use. You have some guidelines also on the Excel sheet that I didn't show you. When you buy this calculator, what's included in this is the monitoring of your area, the carbon assessment stock of your area, the carbon credits applying also, and of course, at the end, you have this beautiful graph of the emission reduction for your projects, which allows you to apply for carbon credits and then have some financing for the feasibility of your project.
I agree with Eric. If the rate is on the other side, it will be better, more convincing. The last question that I've got, it's more on your perspectives, but perhaps they are linked to your first answer, is the in situ measurements. You would like to do in situ measurements. And I would like how, which frequency, and what are the main goals?
The main goals of my in situ measurement I would like to pursue is about the biodiversity credits I mentioned, about the ecosystem services. How do we choose which ecosystem services we will put, will choose to apply for these biodiversity credits? So basically, it will be some kind of review of all the ecosystem services that exist already, to see their impacts on the ecosystem, at what range, if these ecosystem services impacts other ecosystem as well, and for at the end highlights, let's say a few numbers of ecosystem services that could be eligible to biodiversity credits.
Okay, thank you, Alexis. Thank you to all of you.
A lot of question.
Okay, so all good for all of you? Yes? Well, thank you once again, Alexis. Yes, so this is the end of the last session. I want to thank you once again for being here, to support the and to have presented. Thank you for the jury, of course. And we are going to end the live, and we can stay with you, Paola, just like a few minutes. Okay. Merci beaucoup.